Hi everybody. In this video I'm going to go over with you how to compute a confidence interval from raw data, and we're going to be doing this in StatCrunch. Okay, so let's go look at an example here. Here we have high temperatures in degrees Fahrenheit of a random sample of 8 small towns. Okay, so we have these 8 data values here. These are just temperatures. Let's see what it wants us to do. It says, assume high temperatures are normally distributed. Now we're going to need that because we were going to use the central limit theorem here. And to use the central limit theorem, we either need to know that the data is normally distributed or that we have a sample size of at least 30. We definitely don't have a sample size of 30 here. We only have 8 data values, but they're telling us it's normal, so we'll be good to go. Based on this data, find the 90% confidence interval of the mean high temperature of the towns. Okay, a 90% confidence interval. Okay, so what do we know here? Well, we know that the sample size is equal to 8. There are 8 data values here. Okay, and we want to compute a 90% confidence interval. What else do we need? We need a point estimate. We need to find the sample mean. What else do we need? We need to know the standard deviation of the values here. So we're going to need to find S. Okay, and then from that information, we are going to be able to find the margin of error for our confidence interval. All right. The margin of error, remember, is given by the critical t-score multiplied by the standard deviation divided by the square root of the sample size. Okay? All we have right now so far is n. Okay? Let's go to StatCrunch and see if we can get this other stuff. All right. So first of all, we can get our critical t-score without knowing anything else from the problem. All we need to know is that we're doing a 90% confidence interval. Oh, oops, I got my paper in front. So the fact that it's 90% tells me that I have to put a 0.9 here, and I'm doing values between. Okay, so I should have hit between first. 0.9, okay? But I also need to know my degrees of freedom. The degrees of freedom come from the sample size. Remember that degrees of freedom is equal to sample size minus 1. So in this case, it's going to be 8 minus 1, it'll be 7. So we're working with 7 degrees of freedom. There we go. And now we have our critical t-score. I'll just round that to 3 decimal places, 1.894. Okay, so I'm going to write that down here. 1.8. Oh, I'm going to round that to 895. I didn't see there was a 6 after that. 1.895. That's our t star. Okay, now I'm going to multiply that by the standard deviation divided by the square root of the sample size, so that'll be the square root of 8. Right? But what's the standard deviation? How do we get that? Well, we can get that in StatCrunch. Okay, what we're going to do is we're going to go back to our data set, and I'm going to select it. So I'm just dragging over it, and I'm going to hit Control-C, or on a Mac you'd hit Option-C. All right, and then I'm going to come back to StatCrunch, and I'm going to put that, it looks like I was already playing with this, I'm going to put that data into here. I'm going to hit Control-V, or Option-V on a Mac. All right, let me close this distribution down. Now what I need to do is I need to have StatCrunch compute X bar and S. Well, you can do that by going over here to Stat, Summary Stats. We're going to summarize the data, and the data lives in a column, so I'm going to choose Columns. I'm going to select the column. It's the first column labeled var1. And then I'm going to select the things that I want to compute. I want to compute the mean and the standard deviation. Okay, so I hit Compute, and StatCrunch gives me that information. So it's telling me that the mean is 98.09 , about, and the standard deviation is 1.383. Well, look, the standard deviation is what I needed right here. Okay? So now I can compute the margin of error for my confidence interval. I get 0.9266. Okay, so that's my margin of error. Now that we have that, we can construct our confidence interval. Our confidence interval can be written in one of two ways. It can be written as x bar plus or minus the margin of error. That's one way to write it. Another way to write it is to just write an inequality that describes what we are predicting the population mean to be between. So we're going to put x bar minus the margin of error is less than or equal to mu is less than or equal to x bar plus the margin of error. That's what this means. We think that the real mean is somewhere in this range, between x bar minus me and x bar plus me. So this is just being a little bit more explicit about that, saying that we're actually thinking the mean is between these two things. Between is denoted using these inequality symbols. Okay, so what we're going to do is go back to our problem and put this stuff in here. So you can see it's asking for these quantities. This is in the form, the first one that I wrote down. So we're going to write x bar here. Well, we computed our x bar. We got 98.09. So that's what I put there. And we got our margin of error. Margin of error was 0.9266. So there we have that, all right? Now, the other way to write it, right? This is the second way to write it. Well, how do I compute these bounds on the left and the right? I'm going to compute the x bar minus the margin of error. That's going to go here. And x bar plus the margin of error is going to go here. Okay, so when I take 98.09 and subtract 0.9266, I get 97.1634. And when I add, I get 99.0166. And good job us, we got them all right. So just wanted to show you how to do all that. Hope you found that helpful.